Here is another example that we want to work on that together. So with this one, we have two samples of the M1 and N2. For each samples, we have the data points, so we can find out S1 and S2 for them. So in the question, and we have been told that we are working with the two-sided. Our question has two parts. Part A says that test the hypothesis for the sigma 1, like the variance of the first population and the variance of the second population, compare them. And then we want to construct the 95% confidence interval. So from this 95% confidence interval, we can say that our alpha is equal to the 5%. So the first we are going to work on the confidence interval, the hypothesis test, and then we are going to work on the confidence interval. Okay, like always, we want to say that which case it is. So think about it for a moment. We have two samples, and we are interested in the rate to see if sigma 1 is equal to sigma 2 or not, like their variance or standard deviation. So we can say here that we are in case 3, right? Case 3 and two samples. So now let's work on that. For part A, we said that step 1, like for the hypothesis test, step 1 is that what is your parameter of interest? So our parameter of interest here is that we want to know the, we can say if we are interested in the ratio of the sigma 1 and sigma 2. Or we can say the parameter of interest are the variance of them. Like it's going to be sigma 1 power 2, or even you can write that as standard deviation. Both of them are correct. And sigma 2 power 2. So this is my parameter of interest. That's a step 1. A step 2, it's very important that when you are working with the hypothesis test, because we are beginners right now, right? So you would write down all these 8 steps when you are working by yourself. So step number 2 is the null hypothesis. So for the null hypothesis, I would say sigma 1 power 2 is equal to the sigma 2 power 2. Right? And then I have my alternative hypothesis, which says that sigma 1 power 2 is not equal to the sigma 2 power 2. Then I have my alpha, it's 0.05. And then I would have my test statistic. So for the test statistic, we said that when we are in case 3, but with 2 samples, we are going to use the F table, right? So I would say my test statistic is F null is equal to the F observed is equal to the S1 power 2 divided by the S2 power 2. So I'm going to write down here S1 power 2 divided by S2 power 2. Okay. And then, so the origin equation that we have for the test statistic of F, it was S1 power 2, like in the numerator we had S1 power 2 divided by the sigma 1 power 2, and then in denominator we had the S2 power 2 divided by the sigma 2 power 2. Because in our null hypothesis we said that sigma 1 power 2 is equal to the sigma 2 power 2, so those ones they're gonna it's gonna be 1, right? So we would have S1 power 2 divided by the S2 power 2. We have it in the lecture notes, like the video that we have about for this one on the case 3 for the lecture notes. You can look at it. So we have F null here. That's the step number 5. Step number 6 is that find out the rejection, define the rejection region. So I would say number 6, step number 6, rejection region. So for the rejection region, I would say that if so it's like that, but our F observed, right, it's less than or greater than some number, right? So I would say the f observed is greater than f at the half of the alpha, right? And then degree of freedom of the numerator, and then degree of freedom of the denominator. So I would say here n minus 1 and n minus 2. So that's going to be for the, let me just see here. As I said, it's going to be for the numerator and the denominator, like degree of freedom that we would have, like n1 minus 1 and n2 minus 1. If our f null is greater than this, or if our f null is less than the other side of it. So on the left side of it, we had 1 minus half of the alpha, and then n1 minus 1, n2 minus 2. No, n2 minus 1, sorry, for both of them. Okay, n2 minus 1. So this is my rejection region. So that's 6. For number 7, step number 7, we have the computation or calculation. So what I'm going to do here is that I will write down everything that we need to, like all the calculations. The first thing is that f null, s1 power 2 divided by s2 power 2. So I'm going to write down here. So my f null is going to be equal to the s2 power 2. So s1 is 1.9 power 2 divided by the s2 is 1.5 power 2. And then I'm going to put it in the, like the, just the calculator. It's going to be 1.604, I believe. So this is going to be the f null. Then we want to find out the f from the table. I think that's a good opportunity that I would show you how would we read it. We would practice it together. So let's see, what are we looking for? I'm looking for the f is two-sided. At half of the alpha, at 0.025, and then n1 minus 1, n1 is 16, minus 1 is going to be 15. And n2 minus 1, which is 21 minus 1, is going to be 20. So this one is simple, really. So when we want to read it, we go to the F table, and the F table for the alpha, because half of the alpha is 0.025. So when we are comparing these F tables, what we are going to do is that we're going to read that what's written here. So here is that 0.05. No. The next one here, it's written here 0.025. So I'm going to work with this F table. Here on the first column is written degree of freedom for the denominator and degree of freedom of the numerator. So we just need to be very careful that n1 is for the numerator and n2 is for denominator. So in fact, this 15 is for numerator and this 20 is for denominator. So I'm looking for the 20, and then for the numerator I have 15. So it's here, so it's this column, and then 20, I would go all the way, so it's 2.57. So I'm going to get it closer, that you would see how would I read. So I would go 15 here and 20 here, and I would read it. It's 2. I lost it, let me do that again. So it's going to be 15, and then 20, 2.57. So what I'm going to do, as I said, this is the simple one. So I would write down 2.57. What about this one? 1 minus half of the alpha. Look at this. This is very important. So the next one is f at 1 minus half of the alpha is going to be f at 0.025. So it's going to be 0.975, right? So it's 1 minus 0.025. It's going to be 0.975. And then I would have 15 and 20. It's very simple, but we need to know the method for it. So here, when we want to read it, we don't have the F table for the 0.975. So what would we do? We have this rule that this one, listen to this, it's equal to the 1 over, like F for half of the alpha, which is going to be F at 0.025, right? One minus, here is 1 minus half of the alpha, right? So you would write down F at the half of the alpha, and then we need to switch these two. So F at 0.025, and then 20, and then 15. Like at these ones, I have to write down like this. So it's going to be 1 over. Then we go to the same table at the for the 0.025. Okay. So here the numerator and denominator, the numerator is 20 and denominator is 15. It's different than this one. So I would say I'm looking for the denominator is 15. So I'm looking for 15 here and then 20 here. So I have my 20. So when you are looking at it here, so I would say this is 20. I would go all the way down with the 20 and then I would need to stop at the 15. So let me just do this. Maybe it would be easier. I think it's better when I look when I show you like this. So I would say 15. I would go all the way and stop at 20. No, 24. 20. It's 2.76, right? When you read it, so it's going to be here. You can read the number. I would write down 1 over 2.76, which is going to be equal to the 0.389. So this value is F for the F at 0.975, 15, and 20. In fact, we can write down like this. If you are looking for the F, I'm going to write it down as a side note somewhere. Let me see. I have this one here, this one here. I'm going to write down the conclusion here later. Okay, let me just have it like this. So as a side note here, we can write down F at 1 minus half of the alpha, degree of freedom, I'm going to name it df2 and df or df1, like degree of freedom of the numerator and then df2, it's equal to the 1 over f at half of the alpha. So you're going to switch these two, whatever it is, df2 and df1. So this is the equation that we used here. Which is very helpful. Okay? So now we have F null, and we found out F null 1.604. We found out 2F for the lower bound, like for the 2 rejection one. We did all the computations. So now let's do the conclusion. I even can write down a step 8 here as the conclusion, because conclusion is very like short. Let me just use here, and here we can write down, construct the confidence interval. So here, step 8. Look at here, F null is 1.604. The lower bound is 2.57, and sorry, the lower bound is the 0.389, and upper bound is 2.57. So in fact, 0.389, right? This 1.604 is between 0.389 and the upper one. 2.57. So what would be the conclusion? So we said that if this one, 1.604, it was less than this, or it was greater than this, then we would fail to, so we would reject the null hypothesis. But here, we fail to reject the null hypothesis. So I would write down fail to reject the null hypothesis. So this is going to be our conclusion, like step number 8. So we just close the book. Make it like this, it's better. Okay, so next step is that we want to construct the 95% confidence interval. You can do that by yourself, and then you can come back and check the check your answer with us, with whatever I write down here. So for B, we are looking for the 95% confidence interval. It's very easy right now because we already found all of these values, like for the f of the lower one and f of the upper one, the upper bound, all of them we found. So when we are looking for the 95% confidence interval, what are we going to do is that we are going to write down S1 over S2, like both of them is power 2, right? You can write down separately, like the same that we had before. We said before we had that S1 power 2, S2 power 2, right? And then you would say that this one times f at 0.975, right? And for the like the 20 and 15, and then you would have your sigma here, sigma 1 power 2 and sigma 2 power 2, and then you would write down like the S1 power 2, S2 power 2, and the upper bound, like f at the 0.0, it's half of the alpha, 0.025, and 20 and 15. Right? So with this one, we are gonna, just when we are talking about the confidence interval, first for the f, we are gonna write down the denominator and then the numerator. So with this one, what are we gonna do is like, so you would need to read these data. So you know how to read it right now, but you would need to read it again from the table. So what I'm gonna do, I'm gonna write down S1 and S2. I'm just gonna put the numbers. So this one, when you divide them like together, is gonna be 1.604. So 1.604 times this value, when you read it from the table, like reverse it, it's going to be 0.389. And then you would have the sigma 1, 2, sigma 2, 2. And then again 1.604. And this one, as we did it before, so you're going to get the value from the table, 2.76. And we're going to write down the sigma 1 and sigma 2. So sigma 1 power 2 divided by sigma 2 power 2 is going to be between like 0.62 and also 4.43. So this is going to be the confidence interval. And as I said, we can put the equality sign as well. This is continuous, right? So it doesn't matter. So we construct the confidence interval as well. For this one, so this is for the case 3. We worked on an example on case 3. I can go and like stand here, that you would see that like just the, if you want to pause it and write down whatever you need.